The line is racing toward its most critical deadline in 2026. Inside NEOM's desert megasite, crews are working overtime and pushing logistics at a scale that feels more like a space mission than a city build. Today, we'll answer the question of if the line will be completed in 2026, discovering if it's realistic or simply impossible. Out on that site, progress isn't measured in how futuristic the renders look. It's measured in what's locked into the ground and what can no longer be undone. The early deliverable for the line has been treated like a single, concentrated construction target. A first segment where the team can prove they can build the system, repeat it, and then extend it. That's why the most meaningful work so far has happened below grade, because you cannot start a 500-meter tall linear structure by going up. You start by making the earth behave. The job begins with mass excavation to form a long, controlled trench of workable levels, then deep foundations to transfer load into competent strata, then pile caps and ground beams to tie those piles into a unified structural platform, and then raft foundations and basement structures that become the true ground floor for everything stacked above. When people ask how far they are, the only honest construction answer is this: they've been building the substructure pipeline module by module, and the substructure is the slow part that determines whether the fast part can ever happen. The work that matters most for a 2026 completion claim is what changed during 2024 and 2025. The narrative tightened around a first functional zone rather than the full 170-kilometer vision, and the site activity concentrated around a cluster commonly associated with the hidden marina concept. In construction terms, that translates into a smaller number of modules being pushed much harder through the same sequence, because mega projects only become real when they become repetitive. You don't build the line in one continuous sweep. You build one module into a finished piece of structure, then you build the next module faster and the next faster still, until the project behaves like an assembly line. That is why piling became such a major signal of progress, because piling is the first irreversible commitment to geometry. Every pile is a coordinate in the ground. Every pile that passes testing is one more piece of certainty. Once a module's piling campaign is substantially complete, the module can move into the expensive, high-volume concrete work that actually starts forming the footprint of the building. Pile caps, ground beams, raft pours, basement walls, and service-level slabs. Here is what a realistic construction-driven 2026 looks like if you start from where the project has been living. It begins with finishing deep foundations wherever they are still incomplete, because you cannot have a mixed state under a structure like this. If one zone settles differently than the next, you've built a crack into the future. So early 2026 would be dominated by close-out work on piles, verification, retesting where needed, and then an aggressive push on the cap and raft stage, because that stage is the bridge between groundworks and building. This is when the site turns into a concrete production problem. You need continuous batching, delivery, placement, vibration, curing, and quality control at a tempo that doesn't tolerate stoppages. Rafts aren't a simple slab. They're a thick, heavily reinforced structural element designed to spread loads. And once you start pouring them across large footprints, the schedule becomes a race between sequencing and curing. While that's happening, basement construction has to climb right behind it, because basements are not optional here. The line's concept depends on stacked infrastructure, meaning large service corridors, vertical shafts, plant rooms, and transit interfaces that must be built early and precisely because they set the positions of everything else. Once rafts and basements reach a structurally ready state, 2026 becomes the year the project either proves itself above grade or keeps disappearing into the ground. If they are serious about delivering a usable first segment, the middle of 2026 would have to show cores rising, because cores are the spine of any tall structure. Cores establish the building's vertical geometry, carry major loads, and host the systems that make the structure occupiable. Stairs, elevators, risers, smoke control routes, and the service pathways that keep a dense environment alive. With a project like this, you'd expect jump form or slip form core construction where possible, because speed and repeatability are the only way to scale. After cores, you need floor systems and structural connectors that define the space between the mirrored faces, and you need that to advance in a rhythm. Core goes up, floors follow, facade anchors get set, and MEP rough-in starts as soon as the building is safe and stable enough to receive it. That's where the 2026 completion story runs into a wall built out of construction sequencing. Even if a module goes vertical in 2026, turning that structure into an operational environment is a second mega project inside the first. You must enclose the building, and enclosure isn't a cosmetic step. Weather tightness is the moment interior work becomes efficient rather than constantly threatened by heat, dust, and exposure. But facade on a mirrored linear megastructure is a long-led manufacturing problem. It requires design freezes, procurement, factory throughput, shipping, staging, lifting, and installation with tight tolerances because facade alignment errors accumulate. And in a structure that extends linearly, accumulated errors become visible and expensive. Without enclosure, interior progress stays slow. With enclosure, interior progress becomes a parallel machine, electrical distribution, mechanical plant and ducting, plumbing, fire suppression, life safety, elevators, controls, and then the finishing that makes any portion handover ready. So the most credible what will happen this year prediction, based purely on construction logic, is that 2026 is positioned to be a transition year. It is the year they need to convert a foundation first effort into a superstructure first effort across a limited number of modules, while continuing to push adjacent modules through the same foundation pipeline so the site becomes a rolling production line. You would expect to see more simultaneous work fronts, not one heroic tower, but multiple modules each at a different stage. One closing out piling, one pouring raft, one building basement walls, one lifting formwork above grade. That is what momentum looks like on projects that actually scale. If 2026 ends with several modules structurally emerging and at least one module approaching partial enclosure, then the project has achieved the most important construction milestone it can achieve in a single year. Proof of repeatable vertical production. And that leads directly into what happens beyond 2026, because a project like the line only becomes plausible when it behaves like industrialized construction. After 2026, the strategy that makes the most sense is expansion by repetition. Increase the number of active modules, standardize the structural bay where possible, refine the core and floor cycle, lock facade manufacturing into predictable batches, and push MEP installation into prefabricated assemblies so on-site labor shifts from custom fitting to rapid installation. The more they can convert bespoke building into controlled production, the faster each next segment becomes. That is how they go about constructing it long-term, not by building a city, but by building a sequence of giant building modules that connect into a continuous system with transit, utilities, and services integrated in layers that are installed the same way every time. If you want to understand what 2026 can realistically produce on this site, you have to picture the project not as a single building, but as a chain of gigantic structural and services problems that must be solved in the correct order, because construction at this scale is a sequence of gates, and each gate only opens when the one before it is physically complete. The first gate is ground control, meaning the site has to be cut, stabilized, and made repeatable so crews can work with predictable levels and access. And the second gate is deep foundation certainty, meaning the pile field has to be installed, tested, and tied together so the load path is known and uniform. And the third gate is substructure closure, meaning rafts, basements, and the lowest service layers have to be built into watertight, dimensionally correct boxes that won't move, leak, or drift. And only then does the fourth gate open, which is vertical production, cores, floors, and structural connections, rising in cycles fast enough that the project stops looking like a civil engineering site and starts looking like a building factory. In 2026, the construction story lives at the boundary between Gate 3 and Gate 4, because once you've spent years drilling and driving piles, your next challenge is to turn that invisible investment into a visible, repeatable structural rhythm. And that rhythm depends on logistics, formwork systems, concrete supply, and the ability to coordinate multiple contractors so the site doesn't choke on its own complexity. What makes this particularly punishing for any completion narrative is that the line's earliest segment isn't a simple podium with a few towers. It's a mega enclosure concept where enormous vertical surfaces and stacked internal systems have to work together, which means the structural frame and the services have to be planned as one machine rather than as separate trades that can be sequenced loosely. Once rafts and basement slabs exist, the fastest path to visible progress is core construction. And on a tight timeline, the most likely method is a high-output forming system, where core walls rise in a steady jump form cycle because cores create stability, define alignment, and allow subsequent floors to connect. But even cores aren't just concrete. They're dense zones where reinforcement, embeds, openings, sleeves, and connection plates have to be correct at poor time, because fixing them later is slow and dangerous. If 2026 is the year the project wants to show undeniable upward movement, you'd expect the first half of the year to be dominated by core starts across the priority module, plus heavy basement completion work in adjacent zones, because the project needs multiple work fronts to avoid idle time. And that means one area finishing below grade while another starts rising above it. And once the cores begin to climb, you'd expect the next major visible layer to be floor systems, because floors are what turns a tall wall into usable volume. And floors are also where speed is won or lost. If the project relies on highly repetitive structural bays, prefabricated reinforcement cages, standardized formwork tables, and disciplined concrete cycles, it can gain pace. But if the geometry keeps changing, if the design packages keep evolving, or if coordination forces rework, the schedule bleeds out day by day in small stoppages that add up to months. The next construction truth that dominates the second half of 2026 is enclosure pressure, because a project that wants to claim meaningful delivery has to become weather tight. And weather tightness is not a marketing milestone. It's the moment the interior production line can start running at full speed. The problem is that facade on a mirrored megastructure isn't a job you start later. It's a manufacturing and tolerance problem that must be solved early, because the facade system has to be fabricated in enormous quantities, and each panel has to meet visual requirements while also meeting structural movement, thermal performance, and sealing requirements. And the anchorage points that hold those panels need to be embedded and aligned as the structure rises, which ties facade work directly to structural progress. In a realistic 2026, the best case construction narrative would be that the project reaches a point where parts of the first module's superstructure are not only rising, but are being prepared for early facade installation zones, because even a partial facade mock-up installed on real structure is a major proof point that the project can translate design into buildable repetition. And once facade installation begins, you can start interior rough-in behind it, electrical trunking, risers, plant room build-outs, ventilation trunks, chilled water loops, fire mains, and the control systems that coordinate them. This is where the line's stacked city ambition becomes a physical coordination battle, because every service layer needs space, access, redundancy, and maintainability. And when you compress urban infrastructure into a vertical spine, you create intense congestion in shafts and corridors, which forces high levels of prefabrication and disciplined installation sequencing. Otherwise, trades interfere with each other and productivity collapses. If the project leans into modular MEP racks, prefabricated corridor service modules, and repeated plant room layouts, then 2026 could be the year that interior services stop being theoretical and start being installed at scale in at least one prioritized zone. But that still would not mean completion, because installation is only half the job, and commissioning is the other half. And commissioning is where complex buildings spend months, proving that every fan, pump, valve, sensor, alarm, and control loop behaves correctly under real operating conditions. So when you sketch the 2026 timeline month by month in construction terms, it looks less like a finish line and more like a ramp. Early 2026 concentrates on closing out substructure across the most advanced module, while pushing adjacent modules through the same foundation chain so the site never relies on a single front. Spring and early summer are when core systems must rise decisively if the project is to claim genuine vertical momentum, because once cores climb, you can start staging cranes, material hoists, and concrete pumps in more permanent configurations, and you can begin to standardize the cycle time per floor. Late summer into autumn is when early facade zones would need to appear if interior works are to accelerate before year end, because without enclosure, you're installing delicate systems in a harsh environment and losing efficiency. And the final quarter of 2026, in a best case production scenario, would be about expanding parallel work streams, more structure rising, more facade coming in behind it, more MEPI rough-in beginning in protected zones, and more fit-out starting in the earliest enclosed spaces. But the key detail is that these streams do not automatically align in a single year, because structure can be fast while facade lags, or facade can begin while MEP coordination slows, or MEP rough-in can proceed while commissioning remains a distant horizon, and any one lagging stream is enough to prevent any claim of overall completion. What decides whether 2026 becomes a year of real acceleration or a year of impressive looking but still preliminary activity is not ambition, it's throughput. Because on a mega build like this, the schedule is governed by how many cubic meters of concrete you can place to spec, how quickly reinforcement and embeds can be installed without errors, and how smoothly the site can run multiple trades without them colliding. The project's first segment is essentially trying to become its own construction ecosystem, with permanent access routes, heavy lift plans, batching and delivery capacity, storage yards, worker logistics, and a sequencing plan that keeps crews productive every day. And the moment you transition from foundations to superstructure, you create a new set of bottlenecks. Cranes become critical path, vertical transport becomes critical path, formwork reuse becomes critical path, and inspection and quality hold points become critical path, because every floor cycle needs to hit a consistent tempo or the entire pyramid of dependent tasks. Facade, MEP, interiors slides to the right on the calendar. If you hear they are building fast, but you do not see a stable floor-by-floor rhythm emerging across the first module, that's not acceleration, that's activity. And 2026 is the year when the difference becomes impossible to hide. The most construction-specific way to imagine what they are physically building in 2026 is to follow the load path upward, because that's what the contractors are doing in real time. The piles are already the bottom of the load path, then the pile caps and ground beams distribute load into the raft, then the raft distributes into core walls and mega columns, and from there into floors and lateral bracing elements that keep the whole structure stiff against wind and thermal movement. The site has to build those core walls with extreme dimensional control, because in long linear structures, small alignment errors can accumulate into major deviations, and the interfaces where floors tie between faces must be consistent so that the building behaves as a single engineered system rather than two tall walls trying to move independently. That means the superstructure phase is not just pour walls and slabs, it's a constant chore of embeds, connection plates, sleeves, and tolerance checks, because you're building a future facade support grid at the same time you're building the frame, and if those embeds are wrong, you don't just have a defect, you have a cascading delay as crews stop to remediate or redesign. At the same time, while the structure rises, the project has to construct the deep service backbone that makes the concept possible, because a stacked city needs an enormous amount of distributed infrastructure, and that infrastructure can't be slapped in after the fact. What they are constructing below and within the early segment is a layered set of corridors and plant zones designed to carry electrical feeders, chilled water, ventilation trunks, water supply and drainage, fire mains, communications, and controls. And the physical act of building that is a combination of cast-in-place concrete structures for major corridors and shafts, plus early installation of supports, brackets, and penetration frames that allow later services to be hung and routed efficiently. The key construction challenge is congestion, because when you compress urban systems into vertical and subterranean spines, you multiply the number of interfaces and you reduce the number of ways to make it work later. So the only way to keep 2026 productive is to treat MEP not as a later fit-out activity, but as a parallel design and build package that is already being prefabricated and then installed as soon as spaces are protected. That's why enclosure matters so much in 2026, because as soon as you have a weather-tight zone, you can bring in higher value interior trades and run them continuously without losing productivity to exposure, cleaning, rework, and damage. So a realistic second half of 2026 construction snapshot, if things go well, would show a first module with significant core elevation, floors starting to stack in repeated bays, and the earliest facade zones either going on or being staged with anchors and brackets already installed, while adjacent modules are visibly behind but moving steadily through foundation, close out, and basement construction. That staggered picture is not a failure. It's how you build something this large, because the fastest projects are not the ones that push one area to perfection, while others sit idle. They are the ones that keep an even pipeline where every module is always advancing to the next gate. The problem for any claim of completion is that even if one module is far ahead structurally, you still need it to be habitable, and habitability is dominated by the slowest, most integrated tasks: fire compartmentation, life safety systems, elevators and vertical transport, power distribution and backup, HVAC balancing, water systems, pressure testing, control system tuning, and the testing regime that proves the whole environment behaves under load. For a dense, mixed-use, urban segment, commissioning isn't a box to tick. It's a long grind of functional testing, integration testing, and corrective action. And it often expands rather than contracts as complexity increases because each subsystem reveals problems in others when you finally run them together. This is why predicting the project's construction status beyond 2026 is less about dates and more about whether the team succeeds in industrializing the build, because once industrialization happens, the timeline becomes a matter of repetition. Core cycle times improve, floor cycle times improve, facade installation becomes a continuous conveyor, and MEP racks arrive prefabricated and get installed like components rather than built from scratch in place. If 2026 ends with the first segment's production system working, the next few years would likely be about scaling that system, adding more modules, increasing fabrication capacity, and refining the detail set so rework decreases. Because in mega projects, rework is what silently kills schedules. Not a single catastrophe, but 10,000 small errors that each cost a day. The most credible construction approach is a phased handover strategy where one portion becomes operational while adjacent portions remain construction zones, because that allows the project to prove occupancy and functionality without waiting for the entire segment, and it also gives the construction team real operational feedback that can be folded into later modules, improving buildability and maintainability. If you lay the construction program out the way the site has to execute it, the end of 2026 is dominated by close-out work that can't be faked. Watertight basements verified section by section, raft and core concrete signed off with test results, as built surveys confirming alignment, and then the slow grind of turning structure into a functioning environment by installing and proving the internal systems. In early 2026, the site's highest value activity is finishing any remaining deep foundation scope and pushing caps, beams, and raft pours fast enough that multiple modules become structurally ready, because without that platform, you can't start repeatable vertical cycles. And in mid-2026, the only way to show irreversible momentum is cores rising in a stable rhythm, floors following in predictable bays, and facade anchorage being installed as the frame climbs, so enclosure can begin in defined zones. since Enclosure is the switch that allows high output interior work. Once even partial weather-tight sections exist, the build becomes a parallel machine where electrical distribution, chilled water and ventilation trunks, risers, fire mains, and control cabling start filling shafts and corridors. But every meter of services installed creates a future requirement for testing, balancing, integration, and approvals. And those processes expand late in the schedule because defects surface only when systems are run together. By the last quarter of 2026, the site can be full of dramatic vertical structure and still be far from complete because completion requires finished egress routes, commissioned life safety, operational elevators, stable power and backup, balanced HVAC, verified smoke control, pressure-tested plumbing, sealed envelope performance, and documented handover readiness. And the construction reality is that 2026 is far more plausibly a year where the first segment shifts from foundations into visible superstructure and early enclosure, while adjacent modules continue through the foundation pipeline to widen the production line for the years after. That longer trajectory is how the project will be built, by repeating modules, increasing concurrent work fronts, industrializing facade and MEP through prefabrication, and delivering in phases rather than as a single finished megastructure. So the answer to the question is that the line will not be completed in 2026.